it was the previous community call, right? And Todd really excited to see you representing Firebolt at this community call.
Cool. Yep. Oops, I think you're on mute, Todd. But yeah, I just want to let you know live stream started, so we can get going without further delay. So hello, everybody. Happy July. If you're in the Northern Hemisphere, hopefully you're enjoying your summer. It's not too sweltering wherever you are. That's happening here a lot in the US. But just a quick reminder on our code of conduct. We do have one, like all good open source communities. And if you want to see the details, you can go check out our Cube.js repo for full text and details. Agenda is pretty simple. We wanted to carve out a lot of time. We have Todd from Firebolt. Want to talk about, in case you're not too familiar with Firebolt, let me go over what that is, and talk about Cube's integration with Firebolt as well. And we'll do that. We'll start with that. We'll do that after we're done with our community updates for the month. So the first update that I want to provide is that we're going to skip the call in August. I mean, it's not surprisingly, a lot of people are going on vacation in August, and big swath of Europe, for example, is off in August anyways. And I definitely noticed that last year, July and August seemed to be a little slow. So we talked about maybe skipping a call in one of the months. So we'll skip next month. If we have other updates, the one item that I can think of is we probably need to give an update on how we're doing in our open source roadmap. I mean, I was just reviewing the epics yesterday. We're actually doing pretty well. So if there are important updates that we want to provide, I'll do that asynchronously. We can record something and put that on YouTube so that you're not missing out on like roadmap information, for example. But we'll resume our routine in September, and the next formal community call will be on the September 14th. So that's that. Want to provide a quick recap of our last workshop that Igor did a wonderful job of leading. I think it was exactly 2 weeks ago we had our SQL API workshop. I mean, sorry, sometimes I forget to capitalize the L in SQL for some reason, but if you missed the event, I mean, you can check out the videos and slides on the event page. And as with all the workshops, you can check out our YouTube page, and we do have a playlist for all of our workshop slides, so you can go check that out. Some quick stats. One of the things that Igor and I talked a lot about was that for some reason we had a pretty low number of attendees as a percentage of people that registered. So something that we want to work on, potentially engaging with the registered people, for example, by alerting people of setup instructions, etc. But hopefully we'll see better results for the next coming workshop I'll talk about. And wanted to share some of the post-event survey data. I mean, not surprisingly, like I said, Igor did a wonderful job with the material. I think if nothing else, we're probably over-ambitious with the amount of agenda topics. But overall satisfaction rate was good. And then in terms of future topics, I mean, I think the top three wasn't necessarily a surprise, which kind of led me to believe that we're sort of on the right track. I mean, continuation of the SQL API topic, more discussion on data modeling, and some topics geared towards like data engineers or analysts, which I think, Igor, you're going to address in the next workshop as well. So I think we're on the right track, but if you have any other thoughts on future topics, do let us know. Speaking of next workshop, the title is Connecting Your BI Tools to Cube, and it'll again be delivered by Igor. You'll see the agenda topics there. Like I mentioned, we had to skip like discussion on multi-tenancy, for example, and I think there were some questions on security context, and we'll provide updates on other other feature enhancements to a SQL API. And Igor, go ahead. Go ahead and jump in here. Yeah.
Yeah. Thank you, Ray. I just wanted to say that we've engineered this upcoming workshop in a way that it'll still be accessible to those of you who probably haven't had a chance to tune in for our previous one. However, we'll try to tackle kind of more advanced and more tricky concepts, just like this multi-tenancy that you already mentioned, because while they're kind of the multi-tenancy that spans across Cube's data modeling and security and caching layer works just as good for the SQL API like for the rest of the GraphQL API. It needs to be configured slightly differently because of the nature of the SQL API, right? So you're not passing HTTP headers with it, right? So the metadata should be coming from some other way. Yeah. So we'll try to tackle and approach these more advanced topics while keeping this overall approachable, and also just following up on the tremendous volume of work by the product and engineering team here at Cube. We'll be highlighting, and I'll show you how to use Cube with another set of BI tools and data notebooks, and the Power BI and Sigma and Observable Metabase, they are all highlighted here, and that would be kind of an addition to Tableau and Superset and DeepNote and Hex that we showed in our previous workshop. However, I just want to reiterate that obviously this is this is not the list of the exhaustive list of tools that downstream tools that the Cube supports with SQL API, and that's the beauty of SQL API, because with it supporting their pretty much standard industry adopted Postgres dialect, a lot of downstream tools, a lot of BI tools and notebooks and other database tools that talk SQL, they are all now supported by Cube. And probably one day when we have a nice batch of tools again supported by Cube, we'll probably feel the urge to maybe host another workshop, just showing how this new batch of tools work with Cube. Well, but first of all, let's see how this next workshop goes, and I urge and encourage every one of you and the one who will be listening to the recording to tune in and register for this workshop.
Cool. Yeah, Andy, thanks for that additional context, Igor. And I mean, I already got some DMs from people in the community about like new tools that you'll be covering. So definitely looking forward to that. And the one big change that we're making for this workshop is that we've been doing like a 90-minute workshop for quite a while now. Like we wanted to try out like a shorter format, so we'll do this in 60 minutes. Hopefully this will make it easier for people to sort of fit it into your schedule. So that's another big change. And if you haven't registered yet, there's a link there that you can register. And stay tuned. Cool. Moving right along. Just wanted to, in case you haven't noticed, we made some updates to our docs pages on the configuration section. And again, I want to thank Igor for sort of starting this. It was something that was needed. For one thing, we're just having a lot of databases and downstream tools that are on our page. So it was getting, you had to scroll down to find the tools or databases that you're looking for. And we organize each of these into different categories. For example, for visualization tools, we put tools under either notebook, BI tools, or front-end tools, et cetera, et cetera. So hopefully that makes it easier to find. And even data sources, we have different sections for data warehouses, NoSQL database, traditional like a transactional database, for example. So hopefully that's easy to find. And the common questions that we've been getting from community members on Slack and elsewhere is that, which are the drivers are supported by, Cube and by somebody else. And we highlighted those drivers that are community supported, that's not directly supported by Cube, or or the vendors that have contributed the drivers. So hopefully that's easier to navigate. I mean, if you have any questions, please let us know. But I mean, Igor, I'll let you kind of jump in here as well. Like, I mean, let me know if do you want to take control of the screen, if you want to like a screen share, or do you want me to navigate? But,
oh no, you can probably just
yeah.
Switch to the next slide. And
Yeah.
what I want to add here that, well, yeah, as you can see, we've got for example, this is the data sources page, and we got it split by different categories like data warehouses, query engines, document databases, etc. And well, kind of a little bit more abstract comment that I would like to make it that, well, this is probably one of the things that kind of make Cubes distinctive, that it's a kind of a platform. Being a headless BI, it sits between their data consumers downstream and data sources, data stores upstream of Cube. And we've been working on kind of growing this kind of the volume of tool that can be connected to Cube, kind of reaching the point of universal connectivity both to traditional tools in the data space and also the emerging novel tools, right? And probably just mixing, say, Snowflake with SQLite and Mongo and ClickHouse kind of all together. It probably doesn't make much sense, right? So for better structure and also to show that, well, Cube is works equally well with kind of a gray engines and say real-time and streaming databases like Materialize. We kind of highlighted this and made it more evident, from the current structure of these pages in the docs. Yeah, and as I said, we've been working. We're excited to see that the number of the tools that both the tool that Cube supports both upstream and downstream is growing. And here you can see probably the most fresh addition to this. The Firebolt, right? So this is a great addition, and yeah, we are welcoming Todd from the Firebolt team here at this call, so he can tell something about this amazing work of tech and also amazing product, right? And just the last note that I'll make that this is probably the kind of the one of the first interactions that the Cube community has with the Firebolt team. However, we all know that there is some really hot and really technically deep content, right? That we have in our pipeline. We are going to publish really soon about how Firebolt can be used with Cube to building really fast, like blazingly fast apps, right? And I'm excited to push it out soon. But for now, Todd, the mic is yours.
Thanks, Igor. And
probably it makes sense to kind of reshare the screen, right?
Yeah, let me stop sharing. So Todd, if you want to take control, give me a second.
Okay.
There you go.
Well, thanks both of you. And I'm excited to be here today. I've been at Firebolt now just over a year, and it's been a fun ride. Just so you guys have some background. Here at Firebolt, we really believe that you should be able to run queries sub-second, right? Whether it's on a billion rows of data or on a smaller data set. And so my background, I've been in data warehousing for 20 years now. It doesn't seem like that, but when I look back at the time, it is more than 20 years. But I spent 5 years at a little company called Snowflake as one of their first SEs, and then I later helped build out their ecosystem. And so now I'm here at Firebolt to build out the ecosystem here. And really, the idea is to accelerate queries, and the framework that we're looking at, and we see Cube as an important part of this framework, is to build data apps. And we like to kind of differentiate data apps from, little Python thing, Python applications that run on top of data. But data apps are really ways to feed data to users. And one of the things that we have looked at is, a lot of our company comes with experience from companies like Sisense and Looker. and also from Google Cloud. And, we see this huge amount of data now being exposed on the internet. But the problem is that so many of these applications are slow, right? And so we find the statistic that 53% of visitors abandon if it takes more than 3 seconds to load, right? And that's true across all websites, right? Whether that's Amazon.com, where I did work for a while on the retail side, and 3 seconds was like considered unacceptable for a load time. So data applications need to be able to access the data warehouse quickly and refresh quickly. And I know, Cube has a nice little pre-aggregation technology that can help make that happen. But really what we want to be able to enable is you to go directly against the warehouse and get those very fast queries. So the first piece of this warehouse-based data app is that it is built on top of a data warehouse. So we, while a caching layer could be used, we want to go directly against the data warehouse so that we get updates in real time and the data is available. I can go deeper if I want to, and I'm not just tied to what I've cached. Sorry, it took a second to. The other thing is that most often this is customer facing. So internal analysts may be willing to wait a few seconds. I know when I was at Amazon, we would wait minutes for our data because we had such big data sets looking at the click stream. But when end users are looking at data, they don't have that patience, right? They aren't doing that. And again, we want to be serving analytics. We're not talking about complex analysis. This is running queries, slicing and dicing the data. And some of these take intense queries because we're running across billions of rows of data, but we're not running like regression or anything like that. This is, typical analytics workloads, but on huge amounts of data. So it's all about performance, right? Your page can't load faster than your queries run in the background. And so you really have to have a performant data warehouse. Part of this is a well-defined data model, right? You want to control the user's experience. And that's really where Cube comes in giving access to your developers to control that experience of the end users, right? You want them to slice and dice the data, but you don't want them to find, invalid assertions because they looked at the data incorrectly. So you're going to guide them a little bit based on the data. And so it's a very flexible schema, but it doesn't change a whole lot, right? Because you don't want to be constantly having to tweak things and deal with changes in that way. And again, so often this is big data, whether it's video games, trying to make the video game data accessible, the game user data available to the individual users, whether this is ad tech, trying to show you what's happening, whether it's an application showing users the stats within the application. This is data that is very commonly very large. It's event data that's being fed back to users. And so we have to be able to query it. And so these are some examples, right? So marketing data. So you want to see the performance of your marketing data against other data. We have a company called SimilarWeb that does that very well, that shows the difference between your company and companies like you in the space you're in, whether it was retail with Amazon and eBay or other things. And then, obviously there are all kinds of different website metrics like orders, missing items, damaged goods, you can track that. And then obviously search data on the internet. So keywords and different searches. So you can see how people are embedding these apps into the existing apps as a tab where there's a chart or interactive, data at some level. And so we're going to talk about a couple of different ways to accelerate the data. How we can use pruning. Data pruning is one of the key things that we do in Firebolt. We're going to talk about how we do that. We're going to talk about how you can use semi-structured data to eliminate the need for joins. Now, joins are fine in Firebolt. And then we're going to talk a little bit about using partitions so that we can accelerate things like upsert. And then schema evolving. We're also going to throw in a quick note in addition to the pruning on a technique that we call aggregating index. So the first is clustered indexes. And so when you think about a database index, as we've moved to cloud, and I have experience with technologies like Vertica and Teradata where indexes were essential to getting good performance. And then I went to Snowflake where the idea was to be very flexible, right? And so indexes create a problem when you're trying to be flexible. Well, what we're realizing is that that flexibility comes at a cost, and that often we can predict what kind of patterns are going to query against our database. And so if we know what kind of queries are going to run, we can define indexes that are going to help get the data into an order that makes it easy to scan. Because ultimately, database performance is often a physics problem, right? The amount of data I have to scan, I can only compute so much, especially in the cloud, right? With Vertica and others, you had specialized compute. And so when you think about the performance of these query operations, we want a linear access path to the data. We want to make it very fast to find the data that we need. So when they're filtering and they say, hey, we only want to look at 1 week of data out of 7 years, we can get to that week of data very, very fast. And, so we have this ability with what we call a sparse index, that the index doesn't take up a ton of space in the storage, or especially in memory as we're operating. We leverage memory and SSD very, very heavily of the nodes that we spin up. But the idea is that very quickly we can prefetch the indexes and then get the data that we need very quickly, so that we process it and can return results incredibly quickly without having to warm a cache or anything like that. So when you think about how an index is defined, then it's just part of a table. Now, this is a super simple table. I'm going to show you another example in a minute when we do the demo of a much more complicated schema. But the idea is you have a table, it has a number of columns, each of those columns has a data type, and then you're going to define a primary index. Now, in this case, we're picking 2 of the 3 columns as the primary index. A primary index can have as many columns in Firebolt as you want. And again, ultimately, the more columns, each column down the row is going to be sorted. It's sorted in order. So the first column sorted first. So, eventually you get into kind of limited benefit of the additional things. But we want to share with you some of the factors for picking the best column. So number 1 is filtering, right? Usage is what it is. So what are your users querying and how are they filtering the data? Most important, right? So if they're going to be commonly using counts, if they're going to be using a particular field that everybody looks at. So, you have your filter conditions, your join conditions, and then sort conditions as well. So for all of those, it's very helpful. Now, the other thing is you want to remember the granularity, right? So if I have a column that is unique in every row, I probably don't want to include that in my primary index unless I'm doing a lot of work by it. But I can use that granularity to get the performance that I want with my key. And the other thing then is the size, right? So obviously integers are more efficient than strings, and dates, again, are treated very much like integers in Firebolt. So the data type is going to be important. And for strings especially, the length can be a problem, right? If I'm trying to filter by a string, it could be a very costly operation, even if the data is sorted. So really that's this clustered indexes. And again, they're very simple to define. Now, I will say one thing about Firebolt is that as you get started, you may need to play with the indexes, and they are immutable. So you'd need to recreate the table with a different index if you wanted to do that. But that is, that's really the first piece, is filtering the data. Now, an aggregating index is a little bit different. So an aggregating index in Firebolt is very much like a materialized view. It is a physical, we do materialize this aggregating index as a physical table. It's very easy to define. Basically, you're going to define a unique name of the index, and it's going to be on a parent table. So you're going to pick a fact table, in this case, table X. And in this case, we're going to have a single column, which is the date. And then we're going to do a count star and a sum. One thing to note with these aggregating indexes is that the more that we automatically divide the columns into key columns and function columns, we call it, aggregate functions. So in this case, you have one key column, the date, the count, and the sum are both aggregating functions. And that's kind of an automatic thing that happens. You define the key columns first, you define the additional columns after that. And it is completely dependent on the fact table. In fact, you cannot query directly against the aggregating index. But when you query against the parent fact table, if the aggregating index meets the right criteria, and we're going to talk about that here in just a minute, then it will use the aggregating index instead of the parent fact table. So one thing to note, when you do an insert into Firebolt, our aggregating index will automatically be updated with the partner fact table, with the fact table. But it is important to note that it is eventually consistent. So you won't have instant update, but you will have that. It's maintained, so there's no need to do an update. There's no need to set a schedule for updating. It will automatically update. And there is no limit to the number of these aggregating indexes. Now, I think one of the greatest things that they've done at Firebolt is to get those aggregating indexes to build very quickly. And all inserts run very quickly in Firebolt. So you're able to load takes about a second to load a terabyte of data into Firebolt, including with the aggregating indexes. So it is still a pretty quick operation, but the more aggregating indexes on a particular fact table, the more challenging it's going to be. And as I mentioned earlier, when you query that parent fact table, the first thing that our optimizer is going to do is it's going to look at all of the aggregating indexes and decide if any of them would be faster for that particular query. And so I wanted to show an example, and this is with a little bit better table design here. So here we have actually 7 columns, right? So we have 7 columns here. This is just actually the TPCH data set. And that data is, we have a number of columns. We have an integer, which is a key, some text, and a double that is our number that we want to aggregate. And so after we create the fact table, we can then create and generate an aggregating index. So if I create the aggregating index before I populate the fact table, it will automatically stay in sync. But if I'm creating it after the fact, I do need to generate that aggregating index. But you'll notice here then, as we run these queries, the aggregating index has in it, hold on just a second, keeps jumping forward. The aggregating index has the name and the nation key and the average. So any query that hits a subset of those, so this case, it's hitting all 3, and it's going to hit the aggregating index. In this case, we do a substring, and that's okay on one of the fields. So we can do functions on top of those fields as long as we have it. But as soon as we go to a function, so as long as I'm looking at average, but as soon as I go to sum, now it would be easy enough to go back to my aggregating index and add sum here. And actually adding function columns or aggregate columns doesn't increase the cardinality of the table because it just adds a column. But in this case, because we didn't have it, it's not going to run. In this case, then we can even use a where statement on one of those existing columns, and it will still find it. But if we try to then filter by subkey, which is not included in the aggregating index, it will not hit the aggregating index. Now, it's not a big problem if it misses the aggregating index. It'll still run. It just won't go against that. Now, if you want to know after the fact if the command is there, then you can hit explain plan and our explain plan. I'm actually going to show that here in a minute. So just a few notes on those aggregating indexes, that a primary index is generated because it's a separate table. We do generate a primary index, and we do have partitions automatically generated. So you just define it, and the definition is going to set the order of the columns for the primary index. So the entire group by becomes the primary index. And again, the order of the key columns is going to determine how the data is sorted. Now, interestingly enough, if you sort differently than the parent table, then you're going to have the opportunity to have different query patterns, to support different query patterns. So if a user is going against that table, and let's say you have one pattern where you query by date and another pattern where you query by ID, you could create an aggregating index to support the ID case, and then you'd get performance in both cases. Now, one other thing to note, so count distinct can be a little tricky with some of these databases, but if you include a count distinct in an aggregating index, we're going to store all of the data so that the count distinct remains accurate, even at different granularities. And so that becomes really important with that count distinct. Now, when we talk about performance on these, we want the row count to be about a quarter of the parent table or smaller. So we're really trying to reduce the amount of data we're scanning here. So there's really two ways to reduce the amount of data scanned. The first we talked about, which is the primary index and the pruning using the where clause. The other is to say, hey, I'm going to aggregate the data at a grain that gets a lot smaller so that I don't have to scan so much data. So really it gives us that. Now, beyond those techniques, there's a couple of interesting things that we can do. So eliminating joins using arrays can speed up. Now, I will say joins in Firebolt are not necessarily slow, but from a semantic perspective, joins can get a little complicated. And so we're going to show how to use metrics within a fact table using an array. So Firebolt supports array data types. It's one of our key differentiators. And so in order to avoid these large relationships or fact-to-fact joins, we can use arrays. And so we would rather pre-join the tables ahead of time. And using semi-structured objects and Lambda functions, we can do that very effectively in Firebolt. So let's talk about this. So we have two tables. We have an order table and we have a product table. And so, every order has a product ID. So rather than in real time trying to join the data, let's run a query to identify, we want to see the ratio of products with a price increase, and the order data has the price data. The price data is actually in the product table, but we don't know when it was ordered. And so we want to see, use the order data. So now what we've got is we've got a joint combined table with, and thanks Ray for sharing the documentation. But we have a combined table that shows the combined that so now product dates column has been created in product prices so that we don't have to do the join in real time. And so we're able to run the same query much more quickly by doing that. And so we can do the same thing. Again, we're able to do that using the array sort function that is in acceleration. So we're just trying to show kind of how we can make the schema more efficient for loading. So often our customer-facing use cases are very well defined, and we want to be able to leverage some flexibility. So columns may have different pieces in them. There may be fields that don't exist for certain columns, and those, to be honest, are not great in any columnar database. So what we can do here then is use JSON. So a text field in Firebolt supports JSON. And this is just an example of how we can make the app more flexible. So we can define a field as type JSONB or as type text. And so when we do that, then we want to make sure that we pre-extract the fixed fields into the relational column. Right? So it's a combination of relational columns and JSON columns. So when we run this JSON extract, it's going to allow us to pull up fields that we know, and then we can leave the rest of the fields that are flexible in a JSON field in order to do that. And again, we'll share this deck. You guys can see the code here, but we're able to have dozens of keys, and some of those get split into different columns, and then others we're looking up using a hash function. So we're really able to get the JSON saved as text, and we parse it on the fly versus columns that are already pre-parsed and available. So it really gives us that ability to leverage by using the Lambda functions native to Firebolt to leverage that piece. So now I want to take you into an example, and we're going to go in, and I'm going to just show you here the schema that we're going to work with. So in Firebolt, the first thing that we do is we define an object called an external table. So we have an external table for each set of data. So we have an account table that's external, and we're going to point that external table at an S3 location using a pattern and a file format, which happens to be Parquet in this instance. So in order to query the data, we need to bring it into Firebolt. So we're going to create, and this schema here is going to match the Parquet schema of the files in this particular S3 bucket. We're then going to create a dimension table that will allow us to bring in that data, and then we'll have a primary index defined in that. Now, again, a primary index is not a primary key. It is a primary index is essentially the way that we sort the data. In this case, it happens to match the primary key of this table, but it doesn't need to match. And you'll see here in a little minute, we're going to get down to the LTV table. So we have a couple of dimension tables, and now we want to do our fact table. And to point out how we work with this, we first define the external table, we define the internal table, we define any indexes, and then we run an insert from the external table into the internal table. So we'll walk through that here quickly with the LTV table. So the LTV is our fact. This is where we're going to work today. You'll notice we have some things like, hour, country, currency, and then we have some aggregations, things like, impressions count, in-app events count. So this is a real, fact table. We're also calculating on the fly a LTV timestamp to get it down to the day, basically. So we're trying to get a day level granularity there. And then we're going to read that from this location. Again, the file format is Parquet. We're then going to create the internal table that brings in all this data, and we can actually parse and cast the timestamp as a date. And for here, we're going to use, because people query the data most often by date, by media source, and by app ID, we're going to use those as our primary index. In addition to the primary index, we're going to create an aggregating index. And this time we're going to add LTV country and attribution type, because we have a set of queries that rely on those fields. And so here then we have the date format, we're getting a timestamp date, and then we're calculating the sums of all these. Then we do also account distinct, and then a few more sums that are based on case statements. So we can do complex math, complex aggregations as well as basic aggregations. And then we're going to insert into the table all the columns. And one of the things that we're doing here is we're also getting the source file name and the source file timestamp so we could track down when those came in. So that's the SQL that we've run ahead of time. And going into the Firebolt UI, this is where we see those tables. So we've got the tables in our database. We scroll down here, we see account, LTV, and owned apps. If I click on any of these, I see the table names. And so now seeing all that data, we're going to go ahead and go into Cube, and we're going to create a deployment, and we're just going to call this demo. We're going to do it in AWS, and I'm going to pick the North Virginia region. And we're just going to go ahead and create it from scratch, and we're going to connect to Firebolt. So the database that we're going to connect to is the AdTech database. My username happens to be my name. I've got my password stored here. And now we need the engine endpoint. So I'm going to show you where to get that in our UI. So as you come in over here, you go over to the databases tab. And I filtered the list of databases here. So I'm only seeing the AdTech database. I can come over here to my engines. You'll notice that these engines are green, which means they're on, which is an important thing. You need to turn on your engines before you run any kind of a demo. And I can come here and I hit this little copy button. It's going to give me the engine endpoint for that particular engine, which I'm going to need for my Cube connection. And then the API endpoint is always going to be api.app.firebolt.io. And with that information, we're ready to go. So we're going to apply. Let me check here real quick. I think I got my password tweaked. So I'm going to go grab it again from my, I think I'd copied something else in here. Hold on a second. This is always fun when you're in a live demo here. I do have a backup just in case. Let me check again my database name, and we'll try one more time, and then we'll jump over to the other connection here. So make sure it all went in right. There we go. Not sure. I think I got a space in that database name. So first thing I need to do then is check. So in this case, I just want the LTV table. You know, I can grab the account. I can grab more than I want to. I can grab whatever I want. In this case, I'll grab these three. So then we're going to generate. And what that's going to do is that's going to go through my tables, and it's going to take a minute to spin up that deployment. So while we're waiting for that deployment to spin up, I'm going to jump over here, and we've got one that we've already pulled in. So Cube automatically generated the cubes. In this case, I had only done the LTV, so it's a single cube. The one thing that I had to do, Cube identified a number of these comp columns because of the data type as dimensions. And so I had to go into the dimension list and copy some of them into the measures in order to get that to work. And now we go over to the playground. And so here I've got the LTV clicks count. And, you know, again, I can add any of these measures that I've got in there, and then any of the dimensions that I can see. So in this case, I want to see clicks count by country. And I'm going to just do it for all time, although I could filter here. So we're going to hit run. And that's going to run against the Firebolt database. Now, because we're scanning all the data, it took us about 3 seconds, but that's really, you know, what you're going to see, and that's there. And I did want to jump back here to our SQL interface. So with Firebolt, you have the databases tab and the SQL workspace. So here I can run show tables. I can also look at the history. So we have a query history. So I'm going to go look, and I want to see in my query history this query that was run by Cube. So I can see here the query that Cube ran, and it took 3.2 seconds, and it scanned, you know, over a billion records. So it's a big data set that we're running, and we can then take that, you know, we can see all the information about that particular query. So the SQL is automatically being generated. Now, I mentioned the explain plan. So here you can run the explain plan on that SQL, and we can see that it is indeed using our aggregating index, not the parent fact table. But it did have to read the entire table. So obviously, you know, as we filter, it would shrink down that. But we have the ability then to go in and analyze the queries to understand what the SQL that Cube is generating as we work with the Cube. And so, again, once we've created that, we can add joins. You know, the connector does support pre-aggregations if we want them, but typically what we're finding is that, you know, our customers don't need the pre-aggregation. So essentially, you're just going to identify your, you know, your joins, your measures, and your dimensions. I know we've only got about 5 minutes left for questions, but happy to answer any questions that you have.
Well, thanks for running through these. Todd. I got a little nervous when you couldn't get into the Cube Cloud either. That always happens with live demos. But
I think it just was taking a second to spin up the deployment, to be honest.
yeah,
But anyway,
I mean, even the second time, it looked like it was going to work, and it either timed out or something.
But we were able to get it. So yeah, that's how easy it is to get started with Firebolt.
Cool. Yeah, I mean, thanks for tying everything with Cube, and appreciate going through it. I'm just looking through Livestream to see if people have any questions. I don't see any, and unfortunately Igor had to drop off, and as Igor mentioned, we have a blog post, tutorial blog post coming soon, featuring Cube's integration with Firebolt. So more materials are coming soon, so I definitely look forward to that. Yeah, I think we're actually went a couple of minutes over, but that's okay. I mean, people will be able to watch the recordings. Yeah, and thanks again, Todd. I mean, appreciate you coming, and look forward to collaborating with your community as well. And just as we wrap up, just one more reminder about the community call. We'll skip the call next month. I may post some recordings to provide some asynchronous updates, but we'll resume our call in September. Thanks again, Todd, and thanks again, everyone, for attending. I'll see you again soon. Appreciate it.
Thank you so much.
Bye.
Thanks, guys. Bye.
Thanks.